let's chat about the product and quotient rules for logarithms. Here are the rules in bold. I'm going to justify why they're true in this video, and then we'll use them a couple of different ways in a couple of other videos. So first off, let's just say, how would you try to establish whether something was true that said log base b of x plus log base b of y equals log base b of x times y? So I think probably the wise thing to do to start with would be to maybe do an example just to make sure you sort of understand what's going on. What about log base 2 of 4? Okay, I actually know what that is, so I could check it. 2 to the second power is 4. Plus log base 2 of, oh, I don't know, 1/8. I actually know what that is too, right? That's 2 to the negative 3. 2 to the negative 3 is 8. Is that equal to log base 2 of 4 times 1/8? Okay, so really, just to be clear, I know that this one is 2. I know this one is negative 3. And then what's this going to be? If I put these two things together, that's log base 2 of, let's see, 4 divided by 8 is 1/2. And of course, 2 to the negative 1 is 1/2. So yeah, 2 plus negative 3 is negative 1. So that actually makes sense. It actually, hopefully that sort of says, yeah, I know what the rule is. It kind of made sense in that example. That doesn't prove anything to me. What's going on here? Okay, well, first off, when you're dealing with logarithms, often you want to be able to convert them to exponents. So let's just agree that log base b of x we'll call m, and log base b of y, yes, son.
Why?
There's Abe. I'm talking to my students right now, so I'm going to get back to this. But the plastic does look kind of shiny, doesn't it?
It looks like so kind of like.
It looks like snow. Ah, so true.
It looks like
okay.
white.
So this first equation, notice really what it's saying is it's saying b to the m. Oops, b to the m equals x. And the second equation is saying b to the n equals y. Okay, so often when you're trying to prove something about logarithms, you want to think about what would it look like if it was exponents. Okay, so now let's start at the left side of this equal sign and see if we can get to the right side using algebra. Okay, so we have that, and you might say, using the line above, that's just m plus n. Fair enough. I'll just keep the front of that bold to emphasize that's where we're starting. Now, I don't have any exponents there, so there's not much to work with. But do you remember that log base b is the inverse of b to the? So I can put those things together on basically anything, and it doesn't change the value. So m plus n is equal to log base b of b to the m plus n. Well, why would that be relevant? That would be relevant because, oops, let me see if I can underline there. It would be relevant because now I can write that as log base b. Now you remember what happens if you have b to the m plus n. That's b to the m times b to the n, right? That's the property of exponents. Now you might say, why does that matter? Well, as long as you believe that it's true at this step, that's the important thing to me, okay? You ought to believe that that's true. And then in the next step, you'll probably see why I care, okay? So that says log base b of what? Well, what is b to the m? B to the m is x, and b to the n is y. So we have xy. And that's indeed what we were trying to prove in the original thing to begin with, right? So there you have it. That's the proof of this first property. Now, the second property is very similar. You see, the second property says, you know, if you subtract logarithms, if you subtract the output of this and the output of that, that's like dividing the inputs. I hope it's not cheating to say, well, the first thing you're going to do in a proof like that, I'll just copy and paste. That's why this is one video. You say, well, log base b of x, let's call m, log base b of y, you call n, and we're going to try and play the same game with this right here. Okay, so let's see what happens if we start here. You could even pause the video and see if you can practice it yourself, but first off, we get m minus n, then we get log base b of b to the m minus n, right? You can see how that's just what we did above, right? Let's see if we can make that be well behaved and pop down below. Okay, and then I suppose they'd really like that in here. Then what we're going to do is we're going to do the same thing that we did above. We're going to actually use an exponent property, log base b of b to the m over b to the n. Remember, that's what subtraction does. That's like having m many b's in the numerator and n many b's in the denominator. So our last line, our big punch line here, just to emphasize this is equal, our last line is going to say equals log base b of, well, what's b to the m? B to the m is x, b to the n is y. So this right here is just x over y. And that's really what we're trying to prove to begin with. So there you have it. There's both of those proofs all in one handy place.